Yes?
Well, all right. I was born in Golden, Colorado. My father was professor of chemistry at the Colorado School of Mines, and he was a great teacher. And from the time I was a small boy, I used to go to his laboratory and quote, help, unquote, analyze the killer things and stuff, you know. And I think the first real lesson I ever had in chemistry was my folks built a house when I was 4 years old, and in those days a hod carrier slaked the lime by quicklime, put it in a mortar box, and put water on it, and of course it gets hot and so forth. And my father put an egg in there, and after a few minutes he took the egg out and it was hard boiled, and I ate it. And he explained the chemistry of it to me. And so you see, I remember one occasion, I'm sure I hadn't yet gone to school, when I was at his laboratory and I saw a bottle of hydrogen peroxide. I saw the formula HO, or H2O2 rather. And I asked him, why not just write it HO? And he explained to me why it wasn't HO, it was H2O2. So, and I couldn't have been more than 6 years old at that time. So the chemistry never held any terrors for me. So many young people, you know, they come to chemistry and they, oh God, it's a terrible subject, I can't learn it, and so forth, and consequently they don't learn it. But to me it was just natural. And then I went to the University of Colorado, and I don't recall that I ever was asked, what do you want to major in? I took beginning chemistry and I did very well in it. The next fall I came to school. Just automatically, I guess, I don't know, I was signed up in qualitative analysis and organic chemistry. And pretty quick I was a chemistry major. But I don't think I ever consciously set out and said, what shall I major in? What shall I do with my life? It just natural. And so I got my bachelor's degree and my master's degree at Colorado. Then I went to the University of Michigan, and this was a strange thing. I belonged to the chemical fraternity Alpha Chi Sigma at Colorado, and they chose me to go to their national convention in Pittsburgh. I'd never been east of Colorado, and I thought, well, if I'm going to go east, I might as well spend a little while and look around. So I got catalogs of several universities, and I discovered that the summer session at Michigan started just 2 days after this convention finished in Pittsburgh. Oh, okay, I'll go to Michigan. So I spent the summer in Michigan, and I liked it there, and the boys that I met were pleasant to me. So when I was ready to go on a year later to do my doctorate degree work, I went back to Michigan. And I thought then I was going to be an organic chemist. I worked with Professor Gomberg, who of course was a world famous chemist. And so when I came down here, I wasn't interested in free radicals, like we worked on in Michigan. I was interested in molecular rearrangements, isomerism, and I did some research on some molecular rearrangements. In fact, the first PhD student I had majored in organic chemistry on a molecular rearrangement problem. And then one day I was teaching in the freshman chemistry, and we had on the blackboard the formula for, well, the equation, hydrolysis of antimony chloride, you get SbOCl. And some kid in the class said he wanted to ask a question about that antimony hypochlorite. And I said, that's not a hypochlorite. Well, he said, OCl hypochlorite. Well, yeah, but that's not a hypochlorite. Well, why isn't it a hypochlorite? So I explained to him the difference between an oxychloride and a hypochlorite. And while I was doing this, it suddenly occurred to me that if you had a metal with a valence of 3 and you formed the oxychloride, and the same metal had a valence of 1, you formed the hypochlorite, you'd have isomers. I'd never thought about inorganic isomers before. But suddenly it occurred to me, gee, that could be fun. So I went to the library and I looked around it and I found thallium had valency 1, valency 3. So I set out to make phthalic oxychloride and thallus hypochlorite. You can't make thallus hypochlorite because the thallus ion is easily oxidized and the hypochlorite is strongly oxidizing. They destroy each other immediately. But I began thinking of other cases, most of them that I thought couldn't possibly exist, but they were fun. I enjoyed it. I was having a great time thinking up all sorts of isomers in inorganic chemistry. Some do exist, and I found out about them. And of course, this led me into coordination chemistry, where you have all sorts of isomers, cis and trans, dextro and vivo, and so on and so on. And so I got into coordination chemistry, where I've spent the rest of my career. And the very first experiments we did, I was still thinking about organic chemistry, and I'd been interested in the Walden inversion, and I thought, well, maybe we could get a Walden inversion in some cobalt, reactions of cobalt compounds. And I persuaded a senior student to take a shot at it. He was very dubious about it. He didn't think it was going to go, but fortunately it did go. And we published a paper. And that set me off. And though I've spent the whole rest of my career in coordination chemistry of one sort or another, not all in stereochemistry, but most of it, and I'm still doing stereochemistry. We spent some time also on platinum catalysts for hydrogenation of soybean oil. And this was sort of fun, but it was sort of a sideline to what I really was deeply interested in doing. So I soon got back to stereochemistry. And, but I've enjoyed teaching. I've just had a wonderful time teaching. And most of the students who have done graduate work with me, well, maybe I shouldn't say most, about half of them have become teachers. And I've got teachers scattered all across the country, you know, at Northwestern and Indiana and Michigan and Utah and heavens, I don't know, California, UCLA. One man taught at Chicago for a while, and a few in smaller schools. One of my students is at Knox College, and one's at Kenyon College in Ohio. And I'm very proud of the records that they've made. Two of my former students have been presidents of the American Chemical Society.
Who were they?
Fred Basolo and Robert Perry. And the third one is now president-elect, Miss Clayton Callis. And I got a couple more in mind that I hope will be presidents before I'm through. But of course, I don't control this. I can't appoint them. All I can do is give them a little encouragement. And but I think there are a couple of them that still have a strong possibility of becoming president of the society. And that would please me very much. But no, they've done well. This chart that you see here was given to me by one of my former students. The upper part is my own family tree. You see, I worked with Professor Donberg, and he worked with Victor Meyer, and so on back to Lavoisier. Most chemists of today go back to Lavoisier. And then the bottom half of that thing is a list of the students that have taken their doctorate degree that are named together. And the first ones were introduced back in the early 30s. I see, I know where most of them are and what they're doing. I'm in contact with them most of the time. I go to all the classes, all my own ago, so I see them there. Yes, you recognize some of those names, I'm sure. And they've gone into all sorts of chemistry. Well, Gunther Eichhorn's really a biochemist now. And Bob Sievers is an analytical chemist. They have it all sucked in organic chemistry. One man quit chemistry entirely and became a farmer.
Huh?
Yeah. I don't know quite why. I guess he was teaching in a small college, and I guess there's not much future in it. His father and his brother were running the family farm. The father died. The brother thought, well, he couldn't run the farm by himself, so he persuaded this other man to come and help him. And they live here in Illinois, Sycamore, Illinois. But all the rest of them, I think, are still doing chemistry. Well, one or two, a couple of girls who got married and they quit chemistry. But most of them either are still doing chemistry or they have retired, or some have died, of course. Yeah. Well, that's the brief story.
Well, now, how did you get attracted to the platinum complexes for hydrogenation?
Well, the government's Department of Agriculture has a laboratory in Peoria which is devoted to the upbuilding of agricultural products, and they were studying the making of oleomargarine and similar things from soybean oil. And it turns out that soybean oil is a mixture, long chain. Some of these chains are saturated. Some have one double bond, some have two, most have two double bonds. A few have three double bonds. The third double bond gives an off flavor. They said it makes it bitter. Well, it didn't taste bitter to me, but I don't perhaps have a...
I might turn this off.
Yeah, right there. That's it. So they had a couple of things that showed some promise. Iron carbonyl, and I forgot what the other was. And they were discussing this, and somebody said, well, those are both coordination compounds. Yep. Well, if you want coordination compounds, why don't you talk to Bailar? He knows all about coordination compounds. So they come over and ask me, would you do some research on this for us? And they had $60,000. So $30,000 to start with. So I said, well, yeah, I can take a look at it. So I hired a Japanese by the name of Itatani, a very good chemist. And he came to work with me. About that time, I read some papers from DuPont, who discovered that platinum and tin, platinum chloride and tin chloride, formed compounds with each other, and these had certain catalytic effects. So I suggested to Itatani, let's try this, see what it does. So he mixed them up and tried it, and he came to me and he said, well, there's only two double bonds left. I said, now wait a minute, you better do the experiment again, because that doesn't seem quite right. So he came back and he said, no, the third double bond is gone. I said, look, my friend, they gave us $30,000. You can't solve the problem in the first week. Well, we worked on it, and we varied the thing. We put in platinum chloride and nitrate and various other things, and tin salts in different amounts and so forth. And it never was really successful from the point of view of people who were furnishing the money, because they wanted all the double bonds to stay cis. And when we used our catalyst, we could reduce the third double bond down, get down to 2 double bonds, no problem. But the double bonds were mostly trans. And they said, no, this wouldn't do. And so, well, anyway, this went on for 2 or 3 years. We used up the 30,000. They gave us another 30,000. And then about a month before the contract was to expire, they came over here to talk to us, and they said, you know, it would be so much better if this were a heterogeneous catalyst. And I said, wait a minute, our contract says that it has to be a homogeneous catalyst. Well, yes, they said, yes, that's true, but it would be better if it were heterogeneous. Well, I had a student named Bruner working with me, and I said, look, Al, let's make it heterogeneous. So he only had about a month, but he made up this heterogeneous catalyst, which chemically was the same, and it worked the same way. It was very, very successful in reducing the third double bond, but not hurting the second or the first double bond, and except that it turned them from cis to trans. And but that was the end of that. They didn't renew the contract, and I think they're using iron carbonyl now as a catalyst for that reduction. But yeah, I was in this for 3 years, I guess, or 4, and we published 18 or 20 papers on the matter, and which was probably more than we were justified in publishing, but we did it. And it was interesting work. I enjoyed it, and I got quite a little recognition for what we did, though it wasn't what our sponsors wanted us to do. And, but then I went back to stereochemistry, and we're doing now stereochemistry of some platinum compounds. Mostly I worked on cobalt. But the cobalt compounds are, they rearrange very easily. And so if you get one of them, it's apt to change its configuration while you're looking at it. And the platinum compounds don't do that. So lately I've gone to working on platinum, which of course is very expensive. Now, since I'm retired, I can't have graduate students. I did get permission to have undergraduate research students. I have one student working with me now, an undergraduate student. And if I have money, I can hire postdocs. I don't have a postdoc right now, but I hope to get enough money to hire a postdoc. I've had about a dozen Japanese postdocs, and I found them well-trained and industrious, and they're a good group. And now I've reached the place where if I have money, I can write to one of those fellows over in Japan and say, look, I need a postdoc for this and this and this, and he'll send me one.
He'll send you?
Yeah, I don't have to worry about it. I see in chemical engineering ads for people wanting to hire postdocs. Well, I just write to my friends in Japan, and in some way they find a fellow that wants to come, and I think the Japanese system encourages this. If they give a man permission to take a year off to come over here and work with me, or with anybody, I suppose, they don't hire a substitute. The other people over there have to double up and do his work. And he gets his salary while he's here, plus what I pay. Well, actually, they want to come and get a salary at home and a salary here, and so yes, I've had a bunch of them. They've all done well. They've all done very well.
Well, how can the U.S. utilize people who have retired? What could they do that would permit people like you to remain active or more active?
Well, when I reached 68, that was it. You had to retire at 60. Now they've raised it to 70 now. They didn't invite me to come back and do 2 more years. I think the final solution to the problem is to abolish that rule that you have to retire at a certain age. Then the dean or the head of the department, when he feels a man isn't effective anymore, calls him in and says, sorry, we don't think that you should continue. Now that takes some guts on the part of the administrator, but after all, what's an administrator paid for? And I've given a few lectures in freshman chemistry since I retired. People are out of town or something, you know, and I give them a lecture. Why, heck, I can lecture as well as I could 20 years ago. And I'm not sure that I would want a full-time job, but if something happened and they needed somebody to come in and teach, I could do it. I wouldn't mind at all. And I love to teach. And I think that's the answer, really. Some people reach the place where they should retire when they're 50, and some don't reach it till they're 90. And I think I'm more in the latter class than in the former. Because, no, I still have ideas about research, and I'm co-author on a textbook. We're getting the 3rd edition out. Yeah, the 3rd edition will be published in January of this 1989, and I think it's a good book. Whether we get another edition, I don't know. Depends on how this one sells, I suppose. And it's up to the publishers. If the publishers come around and say, well, we need another edition, we'll probably do it. But if they say, well, it doesn't sound very well, let's forget it, well, we'll forget it.
How did you decide to write your first book?
Professor Hopkins invited me to help him write it. He had written a textbook which was very popular and very widely used, and it went through 3 editions, and then he was ready for the 4th edition. He had now retired, and he came to see me and said, well, would you help me with this 4th edition of this book? Well, I said, sure. And he still had an office in the chemistry building, and so every day I'd go to his office and we'd discuss for about an hour, and I'd write, and I soon learned that it was difficult to criticize something he had written. But if I'd write something and take it to him, he'd say, gee, that's good, that's fine. But if I say, no, I don't like what you've done, let me do it, he didn't like that. But anyway, we wrote the book together, and it was very, very interesting. The relationship between us was fine. When we first set out, he said, well, I'm retired, I have lots of time to spend on this, and you're busy with your teaching and so on. You don't know just how much time you can spend. We won't decide how we divide the royalties until we finish the job. Okay, I said, that's fine. So we worked together as we could, and finally we got the book all finished and tied up and mailed off to the publisher. And he says, now let's decide how we'll divide the royalties. He says, you write on a piece of paper what percentage you think you should have. I'll write on a piece of paper the percentage I think you should have, and then we'll swap papers. Okay. I wrote 20 and he wrote 30. So we compromised on 25. So I got 25% of the royalties and he got 75%. And then, well, we did 2 books that way. And then he died, and I did another edition on my own, which I got 55%, as I remember, and his widow got 45%. But it was based pretty much on what he had written, you see. And then it sort of died out. Well, publishers kept coming around to talk to me. Could you write a book on general chemistry? So I finally said, yeah, I'd write a book on general chemistry, all on my own. And I started this, and I thought, gosh, that's a lot of work. So I asked Cyril Moore, who was then on our staff here, do you want to come and join with me? Yeah, sure. So we worked on it, and then we thought, oh, it's still a lot of work. Let's get Jay Kleinberg to help us. So we got Jay, and company, 3 of us. Then, well, we got to have some organic chemistry in this book. We better have an organic chemist come and help us. So we got another man, Cy Gus. Well, 4 of us wrote the book, and we got it all finished. And we shipped it off to the publishers. And they took a look at the manuscript and they said, it'll never do. Never do. Sounds like 4 people wrote it. Oh, there's 4 people wrote it. Sure, what of it? Well, they said you have to have a uniform style. You can't have 4 different styles of writing in one book. I said, look, the bestseller of all time had 60 different authors. Who do you mean? I said, the Bible. Well, that's different. That's different. Yeah, you can't have a textbook that doesn't have a uniform style. So they hired a woman who was a professional writer, and she had some chemical training, to rewrite the book in her own words. And she had a lot more to it. She was a great help. And then they got another fellow to help make up problems. So actually there's 6 names on this book. But it all started because I was going to write the book by myself. But it's a terrible job to write a book. And I don't know. I'm not eager to try it again, even if there were 6 of us to do it.
Now, is that because of the amount of time to collect the material, or are you somewhat of a perfectionist?
Well, part of it is collecting material. Part of it is just the physical writing. I can dictate a book. Some people think they could. Some people can sit down to a typewriter and type it off. I write and then I cross it out. And then I write a sentence and cross it out. And then I write another sentence and cross half of it out. So that by the time I get to the bottom of the page, I've got 3 sentences or something. And it just adds up to a tremendous job. But you have to go to the library and you look things up, you know, to be sure you're up to date and right and so forth. And now the publishers do another thing. After they get the manuscript, they send it out to anywhere up to 15 reviewers. And then these reviewers read it and send it back to the authors with suggestions. Well, then you've got to read what they say. And this guy says they got too many problems. And this fellow says they haven't got enough problems. This guy says the problems are too hard. This guy says they need more hard problems. And I think it's a waste of time myself. I simply want to write the book and send it to the publisher. That's what happened when Professor Hopkins and I wrote together. We wrapped the book up when we got it written. We mailed it off, and that's the last we saw it. And we didn't have the publisher come around saying, well, it sounds like Bailar wrote this chapter and Hopkins wrote that chapter, or anything of this sort. They just took it and published it, and that was it. Well, that's not so bad. Yeah, the 4 of us who started this book, if we could have just written what we wanted to write and shipped it off and forgotten it, that would be one thing. But with having it rewritten by somebody else in different words, and then we had to review all that to be sure that the chemistry was still okay, and then read what all the reviewers said and so forth, it just got to be too much of a headache. And I suppose if somebody asked me to do it again, I'd probably do it. But I'm not sure I would be very happy about it, really.
Well, could you describe Professor Hopkins? You mentioned your first book was with him.
Well, he was the professor of inorganic chemistry, which included all the freshman chemistry at that time. And he was a teacher. He wasn't, well, he did research too on the rare earths. And he was a good research man, but chiefly he was a teacher. When he taught freshman chemistry, it was really a course. He'd bring in, you know, politics, sociology, all sorts of things. He was a very versatile, widely trained man. Before he took up chemistry, he taught classics, and he coached football.
At Illinois?
No. In his younger days, he was at some small college, and yeah, he coached football and played football, And he was, in these days, he would be ludicrous as a football player because he was a very slender man. Nowadays you have to weigh 220 pounds, you know. I don't suppose he ever weighed more than 160, but he was tall and slender, and but he had such a fine spirit. He was old enough, well, his oldest son was just my age, but he was a very formal man. He always called me Dr. Bailar. Although we worked together, we wrote these books together.
And you were that much younger than him?
Yeah, I was Dr. Bailar, yeah, always.
And he was?
Professor Hopkins, yeah. And he insisted that the teachers address their students, freshman chemistry students, Mr. and Miss. And it was very formal. But he was friendly, but never let his guard down to where you could say, well, Hoppy, how about this? He just didn't do that. No.
Was he German trained, or was he?
No, he took his doctorate degree at Johns Hopkins University.
Huh.
And I don't think he'd ever been abroad at all.
No.
He never mentioned it to me. And I suppose I knew him as well as anybody around here. And I would have known had he been. No, he took his degree in physical chemistry at Johns Hopkins. And then he taught in a couple of small colleges before he came here. Now this would not be almost unheard of nowadays for a man to move from a small college to a big university. Because if we hire somebody here, we want him to have shown ability as a research man as well as a teacher. Well, in the small colleges in those days, you couldn't do any research. He taught at Carroll College and at Albion College, I forgot where else. And so he was perhaps 35 years old. I don't know for sure, but I would guess he was probably 35 years old when he came here and joined the staff in charge of, well, he wasn't in charge when he first came. He soon took over charge of the inorganic chemistry and the general chemistry, and kept that position until he retired at 68 years old. Yeah. But I liked working with him. He was a very fair person, and sometimes I didn't quite agree with him. I'd tell him I didn't agree, and well, all right. And we didn't quarrel about it. Then when the chemistry annex was built, I was sent over there to be the immediate boss of freshman chemistry. That whole building is for freshman chemistry. So I was sent over there to sort of supervise, but he was still head of the organization. And so I didn't do things without consulting him unless I had to. That is sometimes a thing that come up, you can't wait, you have to make a decision. But he never criticized me if he thought I made the wrong decision. And, no, we got along very, very well together.
Well, how did you come to Illinois? What led you here?
Oh, well, I had done some teaching as a graduate student at Michigan, and I loved to teach. I thought this is what I wanted to do. I also wanted to be in a big school where they had research. And, well, I had an offer from Eastman Kodak Company to go and work with them. I was just about to get my doctor's degree. But I didn't really want to do that. I wanted to teach. And Professor Willard, who was in charge of the analytical chemistry, got a letter from Professor Hopkins saying they needed somebody to teach freshman chemistry. So he brought the letter to my lab. I wasn't there, and he left it with one of the other boys. So when I came in, he gave me this letter. Here's an opening at Illinois. I went, gee, that's wonderful. That's just exactly what I wanted. And so when Professor Gomberg came in, I showed him the letter, and he rather discouraged me. He said, "Oh, they don't need you at Illinois. They've got plenty of good organic chemists, and no, there's no point in that. You better just forget it." So I took the letter back to Professor Willard. As I entered his office, he said, "Does this interest you?" And I said, "Well, yes," but I started telling Professor Gomberg, said, "No, go." And he says, "I'll get that job for you." It was a Saturday morning, and I explained to him I had to do something about the Eastman Kodak offer. Well, he says, "You go write your letter of application, and I'll write a letter of recommendation." So he sat down at his typewriter, and he typed out a letter of recommendation. And when I had my letter of application, I went back to him. Of course, his letter was all sealed up. He said, "You take this to the post office and mail it." And I explained in my application that I had to know very soon because I promised the Eastman Kodak people I would let them know. So, as I say, this was on a Saturday morning, about Tuesday, I say, I don't remember exactly. I got a message from Professor Hopkins. "Your application has made a very favorable impression. We can't tell you till we hear from other applicants. But on the basis of that I made a favorable impression, I turned down the Eastman Kodak job, which didn't please Professor Gomberg at all because he thought I should have taken it. And but fortunately, after a few days, I did get the offer from Illinois.
Now, what year was this?
1928.
So that was before the Depression.
What's that?
That
Yes.
was,
Oh, yes, yes.
So,
Yes, just a few years before. Originally, the first letter that Professor Willard got, it said the salary would be $1,800 a year, or maybe $2,000. Well, when the offer came, it was $2,100. So, boy, I was just on air. It didn't take me any length of time at all to sit down and write them and say, "I'll be there." And so here I was. And I've never regretted it.
when Professor Willard was the analytical chemist that had written analytical books, how would you describe him? And how did you know him that well?
I had taken 2 courses with him, Advanced Quant, which all the graduate students had to take, no matter what, and Instrumental Analysis. And apparently he thought I had something, I don't know. But anyway, when he saw this letter from Professor Hopkins, he thought of me and he thought, "I'll push that guy for the job," which he did. I had not done brilliant work in his courses. I know it'd been all right, but I was not a star analytical chemist by any means. And but anyway, he had faith in me and he recommended me, and so I got the job.
Did you ever find out what it was about you that
No.
caused him to
No.
see an outstanding person in you?
No, I never looked into it. I came to know him pretty well later. We were on a committee together, and we met in Chicago. He come from Ann Arbor, and I go up from Urbana here. And usually the meetings were 2 or 3 days, so we'd have the evenings free, and he and I would go to a show. He loved to go to shows. He always sat in the front row. And so I'd go to the show with him, and so we got well acquainted, but I never did ask him, "What prompted you to do this?" I better just let it alone.
Well, what were some of the new modern instruments he taught in the course back in the 1920s?
They weren't really very modern instruments. Of course, we had a pH meter, a nephtalometer, if you know what a nephtalometer is.
No, then.
Well, we did sulfur in coal. Yeah, I've forgotten now how you get the thing, but anyway, you get the sulfur in the form of sulfate, and it's not a lot of sulfur, and you add barium ion, and it gives a cloud.
Yes.
And you look through a cylinder, well, it's vertical, you had a plunger up and down, and you determine how deep a liquid you could look through, and still, you compare that with a standard. That was it, I guess. And we had some other simple electrometric measurements. We did some pH titrations and some electrometric titrations of metals, electrodeposition of copper, as I recall. But there wasn't, in terms of instrumental analysis now, you'd think, well, that was pretty simple stuff. But this was a graduate course, stuff that freshmen would do now. And, but it was, I learned some things from him. He was a good teacher, Willard was. A very vigorous man. He didn't marry until he was perhaps 45 years old. And up until that time, he was going out with the girls and having a good time, you know, and so forth. And he'd come to fraternity dances and this one thing and another, you know, just like the boys did. But and he married. He had two daughters. And he had a fine wife and a fine family. And yes, I saw him fairly frequently for many years afterwards. I always counted him a good friend.
Well, now, Gomberg, you worked on free radicals for your PhD with him?
Yes.
How would you describe him?
He was a Russian immigrant. He came to this country when he was 16 years old. Why he came, how he came, nobody knew. Years after he died, I was asked to write a biographical sketch of him. So I went to Ann Arbor and I looked up people that he had known well. And I'd say, what about, I don't know. Didn't he ever tell you? No. You mean to tell me you had lunch with him every week for 20 years and you never learned why he came, where he landed, and not a thing. He never would talk about himself. He was an extremely modest man, very modest, very, almost shy. Quiet, soft-spoken. He never barked at us. But he hovered over us graduate students. He would never take more than 3 graduate students at a time. Never had more than 3, which meant he'd get 1 each year, perhaps, you see. And he'd come into our laboratory 5, 6 times every day. So he saw us every 2 hours. What are you going to do? What have you done since I saw you last? Well, I did just what you told me to. We didn't have a chance to exercise our own judgment, make our own mistakes. But he had a knack, which I never understood. One day I had some stuff that wouldn't crystallize. I'd worked on it and worked on it and worked on it for days, and I just couldn't get a crystal out of it. And I knew it was supposed to crystallize. Well, he came into the laboratory, and I told him, I just can't get this stuff to crystallize. Well, he said, let me see it. So it was in an evaporator dish. I handed him the dish. Oh, he says, that looks very promising. Well, he says, give me some benzene. So I handed him a bottle of benzene. He poured in a little and stirred it around. Now some ligroin. So I gave him a bottle of ligroin. He stirred it in. Bingo, it crystallized. And I said, well, how did you do that? Tell me, what do you do? Oh, he says, you learn by experience. But I don't know whether he didn't know how to tell me. He had an intuition that this was what to do, and he did it, and bingo, it worked. But apparently he couldn't explain to me why he did it this way. And so really we were simply his hands. He told us what to do, and we did it. Eventually we turned in theses, but I was not particularly happy in Michigan. I did enjoy chemistry radical work the way I had thought I would. And in fact, as a matter of fact, I guess I didn't enjoy organic chemistry the way I thought I would, because when I got down here, I quit it. But I can't criticize him. He was a fine man. He was deeply interested in his students. I know he wanted us to succeed. He wanted the best for us, and he worked hard at it. And I liked him personally. He was a very pleasant person to deal with, but as I say, never loud or cross. Sometimes he'd come into the laboratory and I smell pyridine. Who's been working with pyridine? And this sort of thing. If we're supposed to be working with pyridine, he would tell us, well, wait, you're not supposed to do that. But his sensibilities apparently were very keen, and he was a beautiful laboratory technician. His hands were small and his fingers sort of stubby, I think, but he could blow glass like nobody's business. He made beautiful things. And yes, I had great admiration for him, but I don't think he wasn't what I needed as a research director. And I kept thinking to myself, boy, when I get my doctor's degree, that'll be the happiest day of my life. And pretty much was.
Well, now, how big was the graduate school at Michigan at that time?
Oh, not very large, at least in chemistry. They had a peculiar system. Only 3 professors had graduate students. Gomberg in organic, Willard in analytical, and Bartell in physical.
Now, his son is a chemist also?
What's that?
Is Bartell's son a
Yes,
chemist at Michigan now?
That's right, yes, that's the son. But now in organic, there was Blicky and Anderson and Bachman. They didn't have graduate students. Sheffley had master's degrees too. All of the graduate students up till the time I went there, all the graduate students in organic, were Michigan graduates. They would get their bachelor's degrees. If they wanted to go on for graduate work, they would spend a year with Dr. Sheffley. And if he thought they showed promises of work, then he'd turn them over to Gomberg for a PhD degree.
But was that unusual at that time? Setup?
I never heard of it any other place. No.
You know the reason why, or it was just...
I don't know. It was just the way it worked out. In analytical, there was Willard and Cole and McAlpin, Sewell, maybe somebody else. But the only person who had graduate students was Willard. Why the others didn't have, I don't know.
So when you decided organic chemistry was your field, then you had
That was it.
decided.
You worked with Gomberg. Yeah. And since he would take only one new one each year or thereabout, it was very limited. And I was lucky, I think, ever to get an appointment to work with him, because up until that time he had not taken anybody but Michigan graduates. Why he ever took me, I don't know. And I didn't do too well, I'm afraid. I was in the wrong field at the wrong time, but I staggered through it. Then I got down here, and well, it was better. In fact, I was very happy from the day I got here. But
But why don't you describe the day you got here?
what's that?
Describe the day you got here and your impression of it.
Well, I had been home, Colorado, and I came back and I got here, 9 in the morning or something like this, on the railroad train from Peoria. There used to be a railroad run from Peoria across to Indianapolis, Peoria and Eastern. So I got off at Burlington and Peoria and took this train, came over here, carried my suitcase up to the place where I had arranged to have a room. And after I got that settled, I came over here to the chemistry building. And as I told you earlier, I went to the office, and the secretary said, well, you better go and see Professor Adams, which I did. And he spent half an hour, 3/4 of an hour, discussing with me what I should do, not my work here, but how to behave, how to get along, how to work with people. He did ask what research I planned to do and so forth, and he seemed to think that what I said was all right. And then he said, well, you go up and see Professor Hopkins. He will be supervising your work. So I came up here to the 3rd floor, and again, Professor Hopkins spent a long time discussing with me what to do to get ahead in this department, how you go about it. And I was very much impressed because nobody had ever taken that much trouble to tell me what to do to be a success. And so there I was. And I thought this was just next door to heaven. And I still think so. This is a wonderful place to be. And everybody works so well. And I was very lucky. I'd been here 2.5 years, I guess, when the chemistry annex was built. All the freshman chemistry was transferred over there. Well, Professor Eitema was supposed to have charge of that, as he was an assistant professor. But just at this point, he got a job as head of the department at St. Louis University, so he went on. And there were 2 other people, Professor Audrey and Professor Quill, both of whom were somewhat senior to me. They both happened to get fellowships to go to Germany that year. So suddenly here the chemistry annex needs somebody over there, and here's this kid from Michigan. I was only 25 years old. You go over and take charge of the freshman chemistry, which I did. It was a lucky break. You know, if I had been away in Germany, or if the other 2 guys hadn't been in Germany, one of them surely would have been chosen. They were older than I and more experienced. And but it just happened that the 3 people who probably would have been in charge of that work, one of them quit, the other went to Germany for 2 years, and so here I was. And you just fall into it sometimes.
And then you remained in charge of it?
Yes, I did indeed for 30 years or so. And well, I worked under Professor Hopkins until he retired, and then I took over his work as well as my own. And, oh, I worked like a dog here. For 14 years, I handled all the placement work in chemistry and chemical engineering, which meant about 200 people a year getting out needing jobs. And it was up to me to guide them, to help them find jobs that suited them, and so forth and so on. At the same time, I was in charge of the contacts with the architects. We started planning the building Roger Adams Lab across. And so I worked with that fellow. And at the same time, I had charge of the machine shop and the microanalyst. And I was trying to get research done. And I had a staff of 75, 80 assistants, you see, doing the teaching. And I did teaching myself. So I was, I'd get here before 8 in the morning. I'd stay till noon, and I'd rush home to have lunch and get back before 1, just in case somebody had a 1 o'clock class and didn't show up or something. I was here. I stay till 5, and I go home and eat my supper and come back and work till 10, 11, 12 o'clock at night. That's when I got my research done.
You must have had an understanding wife.
Yes. I had a wonderful wife. And we had 2 children along during that period. She did most of the raising of them, I guess. But unfortunately, she died 13, 14 years ago. and I married again, another understanding one. But yeah, yes, I have had a very good life here. As I say, I worked awfully hard, but I enjoyed it. It was the kind of work I wanted to do, and this placement work.
And how did one go about placement at that time? There wasn't a placement bureau or anything like now?
Part of it was the big companies would send representatives here to interview students, and I would arrange the interviews. I would talk to these people who came, and if there was some boy that I thought they'd be particularly interested in, I'd go and find that guy and say, look, I think you like this fellow and he likes you. You better go and see him. And they say, well, look, gosh, I'm just a laboratory clothes. I don't even have a necktie. And I'll learn my necktie, which I often did. And in fact, I brought some neckties in the office so a guy could put on a necktie. And I went to the extreme. In one case, there was a boy in the hospital on appendicitis. And I knew this fellow that came would be interested in this lad. He just, you know, I just felt these two guys would get along together. So I took this personnel man in my car and we went over to the hospital and I introduced him and then I went out in the hall and waited. And well, sure enough, he hired me boy. And well, that was part of it. And then sometimes a student wouldn't get a job this way. He'd have to write letters. Well, I'd help him frame a letter of application, giving suggestions where to send it, and this sort of thing. And you know, when you get to helping people find jobs, pretty soon, a boy will tell you, well, look, I don't want to go there because I want to be close to home. My parents are getting old, and so forth and so on. And then pretty soon he gets to tell you about his girl. And he wants to marry this girl, and she doesn't want to go here or there or someplace, and so on, so on, so on. After a while, you're the father confessor. And I was doing this for 200 people every year. And I made some wonderful friendships. It was great. And of course, it took all day, every day. And but it was satisfying.
Well, what led to your becoming department chairman?
I was never department.
You were never
No.
Just the general chemistry.
Well, I had charge of the inorganic chemistry, yes, which in those early days included the general chemistry. Now it's sort of separate. Well, I don't know. I just grew up into it, I guess, and well, when Professor Hopkins retired, I'd been doing a good deal of the work already, and so I just sort of took over. Nobody said, well, we hereby appoint you. I just did it. And I kept at that until I reached retirement age. And then they brought in a new man to have charge of the freshman chemistry, and somebody else took over the advanced inorganic. And things have changed quite a little since then. But no, it's been a wonderful life I've had here. I've had every sort of job that you can think of. I've been on committees, which I enjoyed. I was chairman of the graduate, what do they call it? The executive committee of the graduate college, and the executive committee of the liberal arts school. And I used to go and visit colleges and high schools. The university used to accredit small colleges, you know. Here's a small college and their students take 2 or 3 years and they want to come to the university to graduate, but the school has to be accredited. So we'd send a team to look the place over and decide whether they were doing good work and whether their students could come here and expect to graduate in a reasonable time. So often I went with those teams of people to evaluate these other schools. And well, this wasn't part of my chemistry work, But I learned a good deal from this. What goes on in a small college? How do they go about doing it? Why do they do it at all? And so forth and so on. And they send maybe 3 or 4 people. One would visit the foreign language classes, and one would, the registrar would talk with the president of the college about the budget and things like that. Somebody would visit the science classes. I'd visit chemistry and physics and mathematics, and maybe they didn't have enough classes to keep me busy all day, so I'd drop into some other class, and see how they were teaching French or something else, just for the fun of it. And as I said, I learned a good deal. We used to go to Chicago, usually in December, I think, and go up there and visit the high schools, determine whether we wanted their students to come down here and enroll as freshmen. And that was interesting too. It's not as much fun as visiting the other colleges.
Well, you travel by train any of these, or you
usually on those trips we drove. Yeah, there'd be only 4 or 5 of us, and enough to fill a car, and we'd drive to Southern Illinois or Chicago or out. Once we went to Eureka College, which where President Reagan was a student. I guess I was there after he was, but they only had one chemistry teacher and one math teacher, as I remember. It was a sort of a rundown place. I think they've pepped up some since then. But yeah, so you see, I've had a wide variety of experience in classroom teaching and research and administration and almost anything a university man can do.
Well, what is the biggest change that you've seen in chemistry in the 70 years or so?
In chemistry itself?
Yes.
Well, it's become much more theoretical all the way through, I think. That is, I would say that's the big change. See, when I started teaching chemistry, we didn't talk about atomic structure. We talked about where do you get cobalt? How do you get the sulfur out of the ground to make sulfuric acid? This sort of thing. And now, see the first chapter, you talk about the structure of atoms. And I'm not sure this is good. A student who's deeply interested in chemistry, that's fine. But if a student isn't really interested in chemistry, well, that doesn't mean much to him. He wants to know, where does copper come from? And that sort of thing. And that's what we used to teach him. But no, the textbooks are all the other way now. And somewhere in between, I think, is where we ought to be. I've sometimes thought about writing a textbook all by myself. I'll start out, things you'd hardly believe. Atoms, how small atoms are, and so forth. And the gas laws, 22 4/10 liters for 1 mole of gas, no matter what the gas is, whether the molecules are big or little. It's hard for freshmen to get that idea. You can explain to them, look, there's a lot of empty space, and the molecules are moving back and forth in there. But some way they don't get that very well. It's hard to put it across. But I think it might be fun to start a book with that sort of thing. Things you could hardly believe, or you wouldn't believe, and build on that. And I don't suppose I'll ever do it.
Well, what kind of a catalyst would get you over that activation energy to do that?
I don't know. I hadn't really thought much about it seriously. I've talked with my wife about it. She's no chemist. She wants to know, what do you teach them and so forth. And I've talked to her a little about it. This is what I would like to do. I'll start out, here's something you don't believe. Now I'm going to explain it to you. This is really the way it is, even if you don't believe it. She'll ask me, oh, why do you believe that? Because if I don't believe it, everything is chaos. If I do believe it, everything falls into place. Oh, yeah. I think I could put it across. Yeah. And that's the only answer, really.
You mean to try to get philosophy included into science, or
You've got to, yes, yeah.
So that you can...
Yeah, that's right. It's philosophy and psychology, but the great majority of the students who come to us are not really interested in being chemists. They want to be engineers, they want to be doctors, they want to be farmers. They're all required to take chemistry. But I would like to get them excited about, gee, that's the way it goes. Yeah. By golly, I do see it. Yeah. Oh, that's the fun of teaching. When you see a student's eyes light up, you say, oh, yeah, I see. That's
That's why I was going to ask you, what is it that gives you the pleasure of teaching, and what makes a good teacher?
What makes a good teacher, I do not know. People have asked me, and I suppose this implies they think I'm a good teacher. Yeah, I don't know. What interest in the student, of course, is one thing. Interest in the subject is another thing. I suppose those are the two big things. You've got a subject that interests you, and you're interested in your students, you want to put it across to them, then you're a good teacher. Well, and assuming that you can put it across. Maybe you want to, but you can't, then you're not a good teacher. But if you want to and you discover how to do it, that makes you a good teacher. Yeah. Yeah. And you've got to go at it in a variety of ways with different students, of course. What works with one student isn't going to work with another student. And you have to keep experimenting and monkeying with it. But I think, first of all, I would say you've got to have fun with it. If science isn't fun, or if teaching isn't fun, you're never going to be a good teacher. No. And I think both of them are fun. Yeah.
Well, what is it that you've seen as the biggest change in students over the 70 years, or are they very similar?
Oh, they haven't changed much. I think they don't work as hard as they used to. I couldn't be sure of that even. But I do have this feeling that they don't dig in as hard as they used to. And I have a feeling they don't come to us as well trained as they used to. I see, well, I usually go home late to lunch, and I come back at 2 o'clock. I see kids, they finish their school today, they're going home. Holy Christmas! I used to go to 4 o'clock when I was a boy. And, 9 to 12, 1:15 to 4. And these kids, they eat their lunch at school, and at 2:30, or 2 o'clock even, they're through. I don't know when they really learn, but well, I don't think they're getting as much in grade school and high school as they used to, so they come to college not as well prepared and not in the habit of working real hard.
Yeah.
The question that perplexes me and has perplexed me for a long time, if you go to Holland, let's say, or Switzerland, the kids can speak English, German, French, and they still have learned mathematics, geography. They learn all the things that our kids learn, and then they learn 2 or 3 foreign languages besides. How do they do it? Why don't our kids learn 2 or 3 foreign languages? Well, the only answer is they don't work at it. Their teachers don't insist on it. And I think our kids are just as bright as kids in Switzerland and Holland. But it takes work. Yeah. I have a granddaughter who's in the 7th grade, and she goes to a private school. And there's some program for the summer. I don't know just what it is, but they had to take the SAT exam, which seniors in high school usually take. These are 7th graders, you see. And the 11 students in her class, 3 of them were above the 50% line in English, math, and science. 3 out of 11 competing with high school seniors. Well, if you can do it in her school, why can't you do it in any school? I don't think she's a genius by any means. She's just an ordinary kid, 13 years old. But apparently the teachers there know how to do it.
And provide the discipline to require it done.
That's right, yeah. And it's a perplexing problem. I don't know. We've got to change it if we're going to keep up with the rest of the world. But our grade school children are not nearly up to snuff as compared with the kids in most of the European countries and in Japan. Of course, when you go to school in Japan, they really work you. Well,
Well, now we seem to be training more and more, or higher and higher percentage of foreign students in
yes,
science departments in the U.S.
yes.
What's your view on this?
Well, I regret that we don't have more students of our own who want training, but since we don't have, the Chinese and the Japanese and the others want to come, why not? Yeah, I think that's fine. I had a clipping just the other day which my sister sent me. The percentage of Japanese students at the University of California at Berkeley was 26%. And then they made some new rules, now it's down to 24%. And the Japanese parents are complaining, you're discriminating against our kids. You're not letting them in the way they used to because of these new rules you got set up. Well, I was amazed that a quarter of the kids in the University of California are Japanese. But, well, if they can do the work, why not? Yeah. Most of them are native point Americans, come from Japanese parents, but they'll stay in this country and they'll contribute to our civilization. I don't care whether they're Japanese or white, as long as they are good citizens. But no, we've got some severe problems in educating our kids. course, we have graduate students here in chemistry, Japanese, Chinese, who do very well. But we say, well, but yeah, they're the pick of the lot. The ordinary Chinese and Japanese don't come here. That's probably true. But even so, we ought to have American students who do just as well as they do. Well, we do have, I suppose, but not as many as we should have. Yeah.
Well, what's the biggest change you've seen in faculty members in chemistry in 70 years?
Oh, it's only 60 years, not 70.
Well, I was counting when your father was teaching also.
Oh. Well, I don't know that the professors have changed so much. My perception of them may have changed, because when I came here, age 24, and Professor Adams was head of the department, and Professor Noyes was still here, and I recognized these were great men. And I looked up to them tremendously. But we may have people just as great now, but I'm a contemporary, or even older than they are, so I don't have the same feeling about them. And I suspect this is true. I don't think the people have changed so much. We still have professors who are good teachers and some who aren't such good teachers, some who are great research people and some who just muddle along. And we try to avoid those if we can, the latter ones. But no, I think it's about the same. Of course, they do a different kind of chemistry. It's much more theoretical now, and much more sophisticated. As I was telling you, this instrumental analysis that I had when I was a graduate student would now be a freshman chemistry subject. And this is true all the way through, I think. So that it's a different aspect.
Well, can you describe what made Professor Noyes a great man in your view when you came here? Or?
Yes. He had retired when I came, but he was still around the building and working. He came here as head of the department. He had done some extremely important chemical research on the combining ratio of hydrogen and oxygen. He'd been president of the American Chemical Society. He founded Chemical Abstracts. He founded Chemical Reviews. He founded the Monograph series. That's it. This guy really did things. I remember him saying one time, when he started Chemical Abstracts, there were 28 divisions, you know, inorganic, organic, analytical, leather chemistry, and so on. And he wrote to people asking each one if he would head up one division of Chemical Abstract. As I recall, all but one accepted his invitation. And he had real leadership ability. He was a small man, insignificant looking, but some way, when he said it, it did. He could put it across. And some of his chemical ideas are no longer accepted by any means. But he had leadership. And when he retired, Professor Adams took over. He had great leadership ability, as well as chemical ability. He published a lot of very important chemistry. But chiefly, I think, his importance lay in the fact that he knew how to judge people and where to set them where to put them in the organization. If they didn't fit, to move them out to some place where they would fit. And those, well, Rhoda Bush was in charge of physical chemistry. He didn't have leadership ability, but he had great chemical imagination. He was the discoverer of the hydrogen bomb. And, well, this sort of thing. They were really top scientists, and some of them had great leadership ability besides.
Well, now, was it a conscious effort for Illinois to become the most productive chemistry department in the United States? Or?
I think Noyes had that when he came, yes. It was rather strange because this was not an industrial state in 1907 when he came here. It was an agricultural state. But he made it known when he first came that he wanted this to be the chemistry department in the country. He was going to make it so. And by gosh, he did. He brought in real top people and encouraged them, got the equipment for them. Of course, this was before I got here, but they tell me that when he needed something for some member of the department here, he'd go to the dean and explain his need for it, and the dean would say, well, yeah, fine, we don't have the money. And he would say, when do I get it? And I tell you, we can't afford it. But look, we need it. When do I get it? And pretty soon you get it. Yeah. Yeah. He was very, very persistent. And, he had no sense of humor whatsoever.
No.
None. I knew his older son very well, when I was junior. He told me that in his whole life, he'd heard his father tell one joke. And it wasn't a very funny joke. But yeah, but that's what made the department. Noyes was head from 1907 to 26. Adams was head from 26 to 54. See, here's a period of almost 50 years when we had two strong leaders. And with that much help, this became a great department.
One of the stories I've heard is about Adams' catalyst. Do you know that story? Or?
Yes. Yes, I've known that story. I think the student involved was named Neville, but I'm not sure of that. But anyway, they're working on platinum catalysts, and this boy stumbled. Platinum fell on the floor. And of course he realized it was expensive. And he realized he was going to get a terrible falling out. So he scraped the floor, dirt and wood and coal, and burned the wood off as well as he could, and recovered the platinum as much as he could, and it turned out to be platinum catalyst. It was a remarkably good catalyst. And this is the way the Adams catalyst was discovered. Actually, Adams didn't discover it. This boy, a graduate student, discovered it. He realized that he had to do something about it or get a terrible falling out. But apparently you have to heat it to a high temperature, so forth and so on, and then you get the catalyst. Yeah. That was before I came here, but Ralph Schreiner wrote me a letter one time and told me this story. I sent the letter over to the University Archives.
On Adams' catalyst?
Yeah. Yeah. Well, I knew if I kept it here, it would eventually get lost. If I would die or something, and people would say, well, let's clear out all this junk and throw it away. So I put it over the university archives because it is the story of some historic importance. Yeah. And if you call the university archivist, he could fish it out and show it to you. Yeah, I don't know how he does these days. He apparently has them all. It's probably in Adam's file.
Well, I couldn't let you finish this without at least mentioning trains and your interest in them over the years.
Trains.
Yes, and your poetry or your poster on trains.
Well, no, I didn't have any great interest in trains. I was on a lecture tour down south, and in those days you went by railroad. And so we'd come to a stop, and I'd see these freight trains sitting there. And they all had initials, CB and Q or UP or whatnot. And I began putting these together in little rhymes and so forth. And pretty soon I thought, well, heck, I could make an interesting poem out of this. So I strung them together and worked at it, for a day perhaps. I remember I had to wait for an hour or so at a station someplace, and I went to the station agent and asked him if he had a railroad guide that I could use for a little while. So he loaned me the railroad guide, and I went through this and looked up names of railroads so I could find some that fit into the rhythm of my poem. And I'd done quite a little traveling for the Chemical Society, either to give lectures or in the visitation. At that time they were visiting departments to determine what they should be put on the approved list. And so just for fun, I dedicated this poem to the woman who arranged the lecture series and the woman who arranged the visitation things. And but that poem had a sort of a swing to it, I had fun with it. I didn't ever think, but anyway, when I got back home, I typed it out and I sent a copy to each of these two women. And the one in the Washington office, they had, I didn't know, they had a house organ for the employees there. And she put it in there, in the poem. And I had a lot of footnotes on it, which never did get published. But anyway, the poem was published in this little house thing. And then I forgot all about it until a year and a half ago or whenever, when the Speaker Service had its 50th anniversary. Somebody dragged out this poem, printed it up, and distributed it around. They made a misprint in it, but that's a small matter. But, then Stocker down in St. Louis, or New Orleans, thought, well, he would have a show called Chemical Trivia, and he asked me if he could put this poem in it. So, sure, why not? And so that's where you saw it, I guess. But it was quite widely distributed before that at this meeting where they celebrated the 50th anniversary of the Speaker Service. I'm still doing Speaker Service work.
Well, why don't you describe your New England trip at what age now?
Yeah, well, when I began to, you see, the way it works, the local sections in an area get together once a year as a representative of each one of them. And they say, well, who do we have to speak? Well, maybe 4 or 5 of them say, we'll have Bill Jones. Maybe another 4 or 5 say, oh, we don't want Bill Jones, we'll have so-and-so. And so-and-so. Then they tell the woman in the Washington office, Okay, these sections want John Bailar to come and give a speech. So she writes to me and says, are you willing to do this? I write back and say, sure. So, then I begin to look into how to get from one place to another. And I found you couldn't do it by air very conveniently. You couldn't do it by rail at all. I called the bus people and they said, oh, you can't do it by bus. You can't get from this place to this place in time to give a lecture each day. Well, the only thing to do then is to rent a car. And so I asked my wife, does she want to go along and drive through New England, which is beautiful at this time of the year. This was almost a month ago. So we flew to Messina, New York. The first lecture was to be at Potsdam, New York. We flew to Messina, which is 20 miles from Potsdam. We rented a car and drove over to Potsdam and gave a lecture. And that, after that lecture that evening, that's when I fell and hurt my leg. But by means of some aspirin to kill the pain, I get a little sleep. Next morning we get up and we drive over to Northfield, Vermont, half-day drive, and gave a lecture there. Then we drove down to New Haven, Connecticut, gave a lecture there. Each night taking enough aspirin that I could go to sleep because my leg hurts like the devil. And then we drove up to Kingston, Rhode Island, University of Rhode Island. And then the next day we drove up to Orono, Maine, which is a long ways up there.
Yes, it is.
Yeah, I gave a lecture up there. Well, in the meantime, before we started out on this, I discovered two things. First, I discovered that if you stay over Saturday night, the airfare is about half what it is if you don't stay over Saturday night. And secondly, I discovered that if we left the car in Orono and flew home, it was a drop-off charge of $200. Well, after all, we have to stay over Saturday. We just drive the car back to Messina, New York, where we got it, which we did. That's a 10-hour trip. Boy, those roads in New England, you know, they go like this. You think it's 120 miles, it turns out to be 240. But anyway, we drove back to Messina and turned the car in, stayed overnight there, so we just saved money on the airfare, flew home on Sunday, and I'm scheduled to give another lecture tour next fall in Texas. I rather enjoy these trips. You meet new people and you tell them about the glories of inorganic chemistry and so on. And you meet some old friends too. So, yes, I've been at this for, gee whiz, I don't know how many years. Somebody in the Washington office told me, I don't know whether he looked it up or anything, but he said that I had given more lectures for ACS section than anybody else ever. Well, this might well be. It's the third time I've been to Orono, Maine. I was there in 45, and again in 50-something, and now again in 80-something. And I suppose if I lived long enough, I'll go back in 2007 to give another lecture. But again, maybe I won't. But I've been all over the country.
Well, now this sore leg also included a broken toe, as I understand.
This what?
This sore leg.
Yes, that's where I twisted my knee and broke my toe. The first night out.
And at what age now did you keep on making the tour with a broken toe?
I was 84 years old last week. Yeah, sure. But there's not much you can do. Of course, I didn't know it was broken, really, until I got home and I went to the doctor. I began to think it was broken because it hurt so badly. But it hurt just as badly if I didn't lecture as if I did, and I couldn't see any point in calling the trip off. These with my wife there to give me encouragement and so forth, we made it all right. But I hope it doesn't happen again because it's no fun.
Well, now, with so much joy out of so many years of chemistry, are you able to pick out anything that just stands out as being the most significant thing from your enjoyment or your satisfaction?
Chemical? Gee whiz, I don't know. I've had so much fun at this business that it's hard to tell where the high spots are. I just couldn't. Of course, when I published my first paper, that was a high spot.
What was that paper?
It was an optical inversion in the reactions of a cobalt complex, like the Walden inversion of organic chemistry. And that was a funny thing about that. I sent the paper to the Journal of American Chemical Society, and I got an acknowledgement. I didn't hear any more. Well, finally, I wrote to the editor, and I said, Professor Lamb, 6 months ago today, I sent you a paper, and I've heard nothing about it. So he wrote back and said, sorry, you get to it. Time went by, and then I wrote him again. I said, a year ago today, I sent you this paper. Well, then he did get after the referee, and the paper was published. And I thought it was a great day. Published 300 since then, but that was a big day. One of the big days was when I was told I'd won the Priestley Medal, which is the highest honor the Chemical Society has. I was at a chemical meeting in New York. Yeah. And word was that Bill Milligan wanted to see me. So I tried to get in touch with him. Finally, no, it wasn't Bill, somebody else. Finally, I was called to the telephone. It was Bill Milligan. And he said, you know why I'm calling you? I said, I have the faintest notion where you're calling. He says, well, you've been chosen for the Priestley Medal. I didn't have the foggiest notion that I was even being considered for the Priestley Medal. Well, I jumped that high. And that was a high point. Yeah. Well, when I learned that I had been nominated for the presidency of the society, my wife and I were in France when my younger son learned that the ACS Council had chosen me as one of the two nominees, sent a telegram. I just wept. I really did. I was just overcome. And, well, that was the high spot. But which is the biggest high spot? I don't know. I don't know.
You've had to jump a lot of them.
Huh?
You've had to go over a lot of high spots.
Yes, that's right. Yes, there have been lots of times that have been wonderful experiences. Yeah. It's been a great life that I've had. More fun, more satisfaction, more happiness. People write to me, my former students. I shouldn't talk to you like this, but my former students write and tell me how much I've meant to them. I hope it's true. Yeah. Yeah, my birthday last week, I had several. Yeah, it's, I suppose that's what really counts. Having your students say, that's what did it. He made me do it. Then, of course, my boys, I have 2 sons.
Yes.
I really should tell you about my 2 sons. My younger son was Postmaster General of the United States. And
Now he's the one that's third, John the Third, or is that?
no,
That's-
this is Benjamin Franklin. Yeah. He, well, I don't know where to start. He was not a strong student at college. He was a good enough student. He was in the Naval ROTC, and he got a commission when he graduated. He wanted to be in the Naval ROTC because he wanted to travel. He thought, if I'm in the Navy, I'll travel. But he spent 2 years in St. Louis. And, but he got a good assignment there. He had a big job to do, running the naval store. He had the store, the filling station, the snack bar, the restaurant. And he had complete charge, a $250,000 business. For a kid just graduated from college, you know, that's something. And he just thought it was great. So he decided to go to business school. And he applied several places. I had a devil of a time getting to apply to Harvard, but he finally did. And he was admitted. And he did well at Harvard. And he, well, I don't need to go into all the details. He worked for American Can and very quickly became vice president of American Can. From that he went to the post office where he became Postmaster General. And then he quit that job to be vice president of the U.S. Gypsum Company. U.S. Gypsum is an extremely conservative company. And they said they wanted him because they needed new ideas. Come in and give us some new ideas. Oh, all right. So he'd think of something, and he'd tell them, well, look, let's do so-and-so. And the reaction was, well, we've never done that. We don't want to do that. And, well, he went on with this for 5 years. They don't want a new idea, so he quit. And he's now dean of the School of Business at Rice University, which surprised everybody, because he'd never had any interest in academic life. They invited him to come down. He went down there, and they offered him the job, and he said no, he didn't want it. He went back home. Pretty soon they called him up and said, we've got some other things to show you. Would you come back again? So he went down again, and they showed him some more things, and they offered him a job. No, I don't want to do it. He went back home, and they called him and said, look, tell us, what do we have to do to get you to come? And he called me on the phone and said, look, if I tell them what they have to do and they do it, I'm committed. I said, yes, you are. Well, he finally told them. If he was going to be dean of their School of Business, he had to be in the business community. He had to be director of a bank in Houston. He had to be director of some other big company in Houston. Okay, we'll take care of it, which they did. So there he is. He's only been there now, what, 6 months maybe, something like that. But he seems to enjoy it. He's having a good time. And apparently, I think he's going to be a good dean. Now, the older boy was much more of a student. He doesn't have the outgoing personality, but he's a typical research man. When he wanted to go to medical school, I hit this as you'd be a horrible doctor. Look, when I'm sick, I want the doctor to come in and say, this poor fellow's sick, let's help him. But you wouldn't feel that way. You'd come and say, gee, that's an interesting case, let's see what's wrong. And but he said, no, I want to go to medical school. So he went to medical school. He got his MD, he took an internship, but he's never practiced medicine. He's a researcher, chiefly on cancer. but not entirely cancer. And he worked for the National Cancer Institute for 20 years or so. And he's now a professor of chemistry, no, not chemistry, professor of medicine in the medical school at McGill University in Canada. Yeah. And I talked to him on the phone just yesterday, I guess. He calls up frequently. And, well, they both do. I talk to them quite frequently. Yeah. And so they've done well. Both of them have done very well. I'm proud of them. But I must say, I think their mother was the one that did it, because I was over here at the chemistry building 14, 15 hours a day. I didn't have time to worry those kids.
Well, do you think of anything else that you would like to include? Or?
No, unless you want me to tell you my love story.
Well, certainly.
Well, I'll tell you. You see, I told you my wife died.
Yes.
And I married again. Now, it's the second marriage I'm going to tell you about. This wife, to whom I am now married, her parents and my parents were good friends before we were born. And when we were little kids, we played together. And there was no thought that I would ever be in love with her or anything of the sort. In 1925, when my sister was married in Colorado, we were at that wedding. And then I went to the University of Michigan for graduate school, and she went to the University of Oregon. So that's it. We were 2,000 miles apart. We didn't write to each other. We didn't hear from each other. I didn't know anything about what was going on, except occasionally she kept in touch with my sister by Christmas cards or something. I knew she married and had children, and her husband died. Well, anyway, time went by. I didn't hear from her. 1975, 50 years after this wedding, my sister and husband had the 50th anniversary, a big celebration. Now, it'd be nice if the people who were at our wedding 50 years ago would come and help us celebrate. Okay. So they invited Catherine. She was still living in Oregon. They lived in California. So they invited her to come down from Oregon to their place, and I went out from here. And I was at my sister's home. And my brother-in-law came in to this woman and said, "John, this is Catherine." I looked at her. I put my arms around her and I kissed her. That was it. We were in love.
After all those years.
That was it. I never had a date with her. No. We didn't get married that day, but we could. We knew. We both knew this was it. Just like that. And so I wrote her a letter, and she answered pretty quick. I called her on the phone. I got to call her on the phone once a week or twice a week, you know. Here, she was out in Oregon. And pretty soon I went out to visit her. And pretty soon we got married. But I didn't know that it could ever be that way. Of course, I knew her background. I knew her parents. She knew my parents, and so it wasn't like meeting a stranger.
No.
But just imagine, we hadn't seen each other for 50 years, practically to the day. And it just hit us both. Just both. Strange story. And we've been very, very happily married now for 12 years. Looks like it's going to last. No, that's the whole story. I don't think I have anything else to tell you.